So this is very, very important terminology, payback period. Okay, so payback is nothing but your investment divided by savings. So there will be payback, maybe it can be called a return of investment also. So payback will give in terms of years, how many years the payback, if I invest the money today of maybe 100 rupees, when I will get this money back. So all those things report will be available in the in terms of a detailed scan, deep scan audit. Okay, then we go into the implementation. That means okay, these are the 10 ideas. Now we need to really implement these ideas step by step. So there will be technical specification. Sometimes large companies go for tenders. Okay, then there is a process to call M&V, measurement and verification. Okay, that means before doing measurement, I know okay, this much of energy consumption happening. Now after you do certain changes or improvements you do, there will be some reduction in energy, but somebody has to validate. Okay, so this is called M&V process, measurement and verification. If there is something called globally, there is something called IP-MVP protocol. Okay, these are the standards available in the internets or Google. So you can see that this is standard available. So this will help you to set the baseline. And once this is baseline is set, okay, we can go into actual implementation happens here. Okay, that means physically the people, there will be replacement of example, LED, sorry, filament lamp to the LEDs. Okay, the physical changes happens here physically. Okay, so there'll be actions which can be done, and from there, yes, we go and do the see the performance. Really, this energy savings are happening or not, or what is the reduction, and we need to keep monitoring these savings every month on month or maybe year on year. We need to really monitor, and finally, you should see that benefits are really coming. So this is how the typical energy audit methodology process goes, and is implemented in the most of industries, and this is the best practices, and this is what you call, this is happening in many years. This kind of process has been implemented last maybe more than 20-25 years. So this process has been implemented in many industries. Okay, so my line is okay, no? Sanju, maybe you can update.
It's absolutely fine, Sridhar. I'm sorry. I'm sure the students are able to grasp it. I'm sure.
Yeah, okay, sorry. Okay, thanks Sanjeev, thanks so much. Okay, so I'll go to the next slide. Okay, now there's something else. There are two types of audits. Okay, the first one is energy audit. Second one I want just to touch upon very high is called harmonics and power quality audit service. Okay, so in power quality audit services, where the people study in terms of electrical reliability point of view, how good is my power. Okay, so normally what happens when in the industries, or it can be buildings also, when you use electrical power, there will be a lot of non-linear loads. Okay, that means like UPS loads are comes under a non-linear category, or maybe the VFDs are there for your various air conditioning systems, so variable speed drives. This all creates a lot of what you call non-linear loads, which creates a lot of what you call unbalance, or creates harmonics in your network. Okay, so now what this harmonics will do. This harmonics is a totally different subject. I'll not go into detail today. So this harmonics can create a lot of what you call non-linear waveform of electrical system. Okay, and this can create a lot of disturbance, like you can fail your electronic components. It can trip your various circuit breakers. It can trip your equipments. Okay, and it can create blackout. Okay, so many times in the industries, you can see suddenly there happens a blackout happens because of some tripping of breakers, or maybe suddenly you can see some electronic components fails in a back-to-back, the PCB cards fails. So all this leads to your harmonics creates, and there are two type of harmonics we can tell in a categorize. One is voltage harmonic, total harmonic distortion, we call VTHT. Other one is called ITHT. Okay, so these are very commonly used terminologies we used to. So typically, as per the IEEE standards, the current harmonic should not exceed more than 8%. Okay, so if it exceeds 8%, that means this particular facility has a lot of harmonics related issues, and you need some mitigation solution. Okay, so this is very important. So sometimes yes, as a part of the energy audit study, we include this also power quality study, so that customer not only see the benefit of energy cost saving, they see sometimes in terms of electrical reliability also, that yes, my facility is a good efficient, but it's various tripping happening, a lot of my what do you call frequent blackout happening. So we need to really find some solution for this. So such cases people go for this kind of power quality audit studies. Okay, so but approach is same. So the way of doing energy audit and power quality audit approach is same. Some people do in digitally, some people do sometimes you capture the data through various this kind of power meters. We capture the data, because there are some events called sag, swell, and you can see transient. So these are the something the voltage goes suddenly goes more than 120 times or 150 times or maybe 200 times sometimes, and it can go and trip some equipments. Okay, so those events happens in a few microseconds or milliseconds or nanoseconds. Okay, so those kind of instrument happening, we need a very high-end power meters are required, which can really capture those kind of information. Okay, so normal traditional the energy meters will not be able to capture. So yes, sometimes we use these kind of instrument for the audit purpose, and we install these equipment in the main transformer area, where you get 11 kV volt. Step down happens to the 415 volts before it comes to industrial area. So these kind of instruments are required or will be help us to really capture. So whenever this event happens, this meter captures and stores that in the data in the metering. So this is very important way of technology. Then we analyze and we'll find the mitigation solution. Okay, so there are two type of audits happens typically in an industrial environment point of view. Okay, now we'll explain how we conduct energy audit. Okay, so energy audit is very beautiful process. Normally we conduct. So first thing is we should prepare for the audit. So before, once you decide, okay, I want to do an audit for your facility. Okay, we should prepare in advance. Okay, how do you prepare? So we need to send a checklist. Normally we send a checklist to the customer or maybe the party who wants to do energy audit. It can be a buildings or it can be a data center. It can be any industries typically. Okay. So it can be our own house, for example, if you are doing audits. So first you need to prepare checklist. Okay, what are the things, what are the type of energy you are using? Okay, then where are the areas you want to do measurements? Okay, we should understand how your facilities are, your house are operating. What is your operating time of your house? Maybe people wake up at 6 o'clock and maybe sleeps at 10 o'clock, for example. So we know your operating hours of your particular facility or house or maybe industry. Okay, then we should know which are your major energy areas we should target. Okay, maybe in your house, maybe you're using air conditioning system, or maybe your lighting, maybe your refrigerator system, or maybe your geysers in your restrooms. Okay, so all these things area will help us to know. So you should plan in advance before you go to the particular facility or industry. So this is called planning. Basically we do planning. Okay, so this is the first step and very important, because if you don't plan and if you go to the facility, we will be completely dark. Okay, and we waste a lot of time there, and finally the effort it requires is more, and also the end users feel discomfort because you are wasting time and no proper planning. So this is very important we do. Secondly, we prepare a file with historical data. That means first thing is we should prepare the historical data we should collect from the particular facility. Okay, historical data means your energy bills. Okay, what is my energy bill of the particular facility? Okay, maybe my last 1 year. Normally we take a 1 year period. So because of weather condition, some are extreme summer, some are sometime it will be extreme winter. So your energy patterns also will change accordingly, because people use extreme air conditioning in the summer and very less in the winter time. So all those things will happen accordingly. So there will be a lot of variation in the energy pattern. So we need to capture the energy consumption data for at least 1 year. Then your equipment details, various equipments, or what are the equipments you have in your facility. So typically you have generators. It can be in apartments, you have generators, you have transformers will be there. You may have some air conditioning system in your respective homes or in your buildings. So we can see sometimes there'll be air handling units, sometimes there'll be chiller systems, air conditioning systems, all those things will be there. So we need to really map, get the profile done. So this profiling is basically how we do is basically doing the measurement, or sometimes they will do the log report. That means somebody will be writing the data in a logbook. Okay, so this is commonly best practice in the industries. And buildings, sometimes yes, they do, some places they do the logbook recording. That means every hour or maybe every day they will go and record what is my energy consumption of the generator, what is the transformer, then your UPS loads, then your air conditioning system, lighting system. So somebody will log the data of the energy data through an energy meter, whatever the instruments are installed there, and is captured. So this is the second preparation we do. Thirdly, yes, wherever there is no measurement, we need to use a field measurements. That means instruments. So we'll be using a lot of instruments which will help us to really capture the electrical data, mechanical data, thermal data. Okay, so these parameters are, so they're a portable instrument. That means like carrying instrument, and we can install this live. I'll show you some examples also. So these are the instruments we carry, and we connect to the various R phase, Y phase, B phase. Typically, the most of industries or buildings, large buildings, so will have a 3-phase power near the transformers. Okay, so we measure the power with a 3-phase. Sometime if it's a house, it will be single phase also. Yes, we can take the measurement through various power meters or power analyzer meters, and this takes the data in terms of data logging. Okay, then we analyze the data. Okay, we see how the energy usage happening, how is the energy balance. Okay, so if I do the energy balance, is basically if I'm consuming my total the main power into my house is, for example, 5 kilowatt. Okay, for example, okay, I should know who is consuming this 5 kilowatt. Maybe 1 kilowatt is consumed by the refrigerator, maybe 1 kilowatt by the geyser, or maybe some lighting loads. Okay, so basically we should know who is consuming the power. So it's called energy balance. Okay, and benchmarking is basically, okay, now this power consumption for example, in an apartment, house number 1, there are 5 people in that house and consuming maybe 5 kilowatt. So average per specific energy consumption for benchmark is 1 person 1 kilowatt. Similarly, if there are 10 people in another house maybe, and they should consume typically 10 kilowatt. Suppose if they're consuming maybe 15 kilowatt, that means they're using more power than the actual people compare. So like that, we can have a benchmarking happens in the most of industries. Okay, then we identify the energy conservation measures. Okay, so where are the opportunities we have energy conservation measures. Okay, then cost benefit analysis. So cost benefit analysis basically like, okay, if I do some changes in this particular facility, how much cost benefit I'm going to get. Okay, is there any beneficial in terms of energy cost reduction, or is there any benefit in terms of failure of any equipments. Okay, it can lead to my cost benefit analysis. So there are many cost benefit analysis will happen also. So I'll show you some examples in my audit report how it can be done. Okay. Then there should be a closing meeting. So once you do the audit, there should be a finally conclusion should be there. That means you should bring your end user, or maybe your respective customer, or maybe your the party who wants to do the energy audit. So there should be a closing meeting. That means you need to sit across the table, explain these are the ideas or observations you received, and there should be acceptance from the customer. Yes, this is a good idea. We should have saved here. We should have done here. So they will accept these ideas or energy conservation measures. Okay, so then this acceptance is very, very important in this closing meeting. Then only we should go into the next level. Okay, then once you do the consumption, acceptance of energy conservation measures, that means ideas, then the draft report will prepare. That means people will go back to your respective offices or maybe your house, and you can start preparing on the audit report. I'll show you some sample audit report, how you prepare the report. It's like long report of maybe 40-50 pages, sometimes 100 pages. Okay, so we prepare this kind of report and explain understand the list of energy conservation measures, and to get the feedback customers. And finally, yes, the final report gets accepted or prepared with cost benefit data collected. Then we give the who can do this kind of replacement, who are the vendors who can supply. For example, like replacing LED. So there are many vendors available in the market who can give the best different type of LEDs. So again, we have recommended vendors who can give the most efficient LED lamps, which is certified by your Bureau of Energy Efficiency with a different star rating, star 1, 2, 3, 4, 5. All those things are available. So we can recommend the right vendors who can supply the best energy, most energy efficient solutions to the customers. So this is how the auditing process happens. Okay. And also we can do the final presentation. That means finally you should present. Once the report is done, it will be typically in a article in a PDF file, or maybe in a document in a report. But finally you need to present to the management or the customer's management or customer user management. Okay, these are the ideas, these are the observations. So there will be a lot of debate will be there. So this finally is the way of our methodology is to we should present this information as a part of the closure meeting, as well as the final report presentation happens. Okay, so these are the few audit instruments. So you can see power analyzers. You can see this is a very, very important. So this is how the power analyzer measurement happens. Then temperature loggers to measure the temperatures of the various parameters we should use. Then for airflow rate for the various pitot tubes we are using for measurement for gas and flow rates. Ultrasonic water flow meter to know what is the flow rate of the water. Chilled water, basically tachometer for speeds. Then flue gas analyzer for in the furnaces, boilers we use flue gas analyzers. Anemometer for the speed. Then pressure gauges to know the pressure. Then dry bulb temperature, what you call wet bulb temperature and dry bulb temperature, and RH meters. Okay, then thermal imaging for insulation study. So these are the various types of instruments we use carry when you go for audits. So yes, so if you are if you want to build your career, or if you have want to become expert on energy audits, yes, this kind of instrument is a must to have with you. So there will be some investment, or there should be like preparation will be required for this kind of instruments are required to really take this instrument, take it for measurement, and prepare this kind of audit report. Because finally the data, we need to get data, only this kind of instrument can help you to get the data, and only based on the data only we can make the analysis and generate the energy conservation measures. Okay, now I'll explain how the audit measurements to be taken. Okay, for example, when you go for typically any buildings or any industry, so electrical system, the first priority or first where most of the power is like 70 to 80% power is being used in the most of industries are electrical. Okay, and then remaining will be thermal energy, like your fuel and other parameters comes as a part of the system. Okay, so this transformer is the first thing. So you should know what is the transformer loading pattern. That means this is like the main entrance of your facility, or maybe it can be a building, it can be your apartment, it can be your industrial area. So the transformers is the first gateway. That means you are entering, the main door is like your transformer for electrical power. So we should see how much is the transformer loading pattern. Is it for example typically 1000 kV transformers will be 1000 kVA and above, maybe sometime will be 500 kVA, sometime large industries will have maybe up to 7000 or maybe 10,000 kVA also. Okay, but we should know how the loading pattern happens. So if the loading pattern, typically the best loading pattern is between 40 to 60%. Okay, for typical transformers. So but to keep your iron loss and copper losses trying to maintain here. So nowadays you get more energy efficient transformers, the loading can go up to maybe 70-80% also. So we need to know what is the loading pattern and what are the losses happening in terms of loading. Okay, then your capacitor performances, like what is the power factor? So the typically in when the power comes, there will be two type of power. One is active power, other one is reactive power. So we should know. So and also apparent power. Okay, so these are the three type of power normally monitors in the transformer level. So ideally, the apparent power and your active power should be almost near to equal. That means your power factor plays a very important role. So that you should maintain the unity power factor as near as possible, like 0.99 power factor is very important. Okay, so we need to see what is the power factor level. If the power factor is very low, that means your losses are more in terms of electrical loss, electrical distribution losses will be more. So people normally in any industries or maybe in buildings, we see that power factor is maintained 0.99. So many states are gone with kVH billing. Okay, so where they want to recover the losses indirectly. But in Karnataka and many states, still we are in kWH in terms of billing point of view. So yes, so this power factor plays a very important role here, and we need to measure the data. We should see sometimes there will be capacitor banks used for improving the power factor. We should see how the capacitors are working. Sometimes capacitors can fail, and it can show by measuring the current of the capacitors. We know that yes, capacitors are working efficiently, and the power factors are improving. So these are the various measurements we take to know what is the performance of the electrical system. Then second comes your electrical motors. So these are the major loads in the typical industry. So if you see in the industry, like 70 to 80% are most of the motors or pumps are used. Operation happens through this electrical power consumption. So yes, motor loading is very important. So lesser the motor loading, that means the motor is running inefficiently. Okay, that means typically 70% and above the motor loading should be there. At the same time, power factor should be very high as possible, like 0.8, 0.9. And 0.99 plus is better. Then how the controlling of motors. Okay, so motor operation is very important. Star, delta, then VFD based motors. So there are many controls are there where you can control your motors. Again, your affinity law comes here in the picture. So 120F by P, all those things comes under this category of motor, where you can really analyze your how we can make the motor efficiently operate. All those things comes, plus your type of technologies. Okay, technologies of motors are very important. For example, like energy efficient motors are available in the market, and again there are a lot of ratings, class 1, class 2, class 3, class 4. So again, we should see that most efficient energy efficient motors are used in the industry, which will consume less power, and your operation will be very smooth, and longer life has its own benefits. Okay, so again, this we need to measure. All these parameters has to be measured through your various power analyzers and various instruments. Very important. Then comes pumps, fan and blowers. Okay, so again, pumps are used for water circulation or maybe any liquid circulation basically. And fans are used for circulation of air circulation. Fans are used. So again, efficiency of these fans are very important. Pumps are very efficient, very important. So we should know how the flow control happens. Again, mechanism for pump flow. Okay, so again, your affinity laws will come here in the picture, like how to improve the pump flow rate. So by reducing the, okay, for example, in the pump, the flow rates are controlled by throttling normally. Okay, that means there will be a ball valve which will reduce the flow rate, so that pump water flow is controlled. But that is the most inefficient way of doing the what you call flow control. Okay, so that means ideally if the pumps running with a motor, typically the motor will be driving the pumps actually. So by reducing the RPM of your motor, that means your RPM basically like your speed of the motor. If you reduce the speed of the motor, your flow rate also can be reduced, and accordingly your energy efficiency also improves and energy cost saving happens. Okay, so it's a beautiful way of doing energy efficiency for pumps, but we should know how the flow control has been done for a pumps or fans, and finally you can optimize the various energy savings on this particular pump. So again, we should know what is the electrical power consumption, and then we should know what is the hydraulic power based on the flow and head pressure. We should know what is hydraulic power which has been fed to the pumps and other areas. So by the dividing hydraulic power and electrical power, we'll know the efficiency of the particular pumps and blowers. Then next is the compressed air. So I am not sure you will be heavy for you to know the compressed air, but compressed air is a very, very popularly used in industries where the air is used for pneumatic applications. For example, if a door of a machine or a furnace doors, or it can be any equipment doors, there will be a lot of pneumatic systems or air circulation happen in industries. So this air, the input for this compressor is electrical power. Output of a typical compressor is a high pressure air. Okay, the pressure of the air will be almost like 7 kg per centimeter square, or maybe 10 kg per centimeter square. So that means high pressure air has been produced, and this air is used in a industrial environment for operating your various pneumatic systems. Similarly, it can be air conditioning system also for your buildings. There'll be air conditioning system. So again, the input for the air chillers will be, or air conditioning will be electrical power. Output is a chilled water flow, or maybe your cool air. So depending on the type of industries, yes, we have measurements being planned actually. Okay, so typically now I'll go to typically energy audit recommendations. Okay, after you do the measurement, okay, now how you should be able to present this data to your typical end users, or maybe your customers, or maybe your wherever you are doing the audits. So okay, the first thing is, yes, you have a energy consumption should have simple payback period of typically maximum 3 years. Okay, so that means anything more than 3 years, most of the customers will not be attractive. They will not invest the money. Okay, then your energy consumption measure should help in improving the specific energy consumption. That means input and output. Okay, and final reduction of your operating cost, enhancement of your production, or it can be occupancy of your particular building. Okay, environmental impact. Okay, and finally your this energy consumption should be categorized in your with low investment, payback, or very, very low payback. So these are various deliverables will come as a part of recommendation. So if you see right side, you can say typically when we do a audit for a hotel. Okay, so you see in a hotel, the maximum energy usage or happens in the air conditioning system. You see, hotels are mostly air conditioned. Now I'm talking about large 5-star hotels and hotels. So air conditioned hotels, you can see. Secondly, they use a lot of steam and hot water system. So 90% is a various hot water system. Steam is used for your kitchens, restaurants, and all those areas. They use a lot of hot water system. Then lighting is 84% major usage happens in the lighting. Then power distribution 68%. Then ventilation and air circulation comes under 56%. Then water treatment. So these are the major areas where the power consumption happens in large hotels, 5-star hotels and all. So normally when you do audits, yes, so we see that what is the investment required, what is the energy saving coming here, and you can see the payback period in terms of months. Okay, so this is very, very important to know. Okay, if I want to get the savings of 38 lakhs per year, okay, I should invest 54 lakhs of rupees. That means I'm getting this money back. Whatever the investment I do, this money I will get money back in 17 months. Okay, similarly, if I find some energy cost saving benefit in the steam and hot water system, I'm getting 13 lakh savings. Okay, but I need to invest 16 lakhs. Okay, that means I need to do some corrections and all. So such cases you need some investment. But important from the senior management point of view, or maybe your the decision maker point of view, he will think, okay, I am getting this 13 lakhs benefit, I will get this 13 lakhs benefit, but if I invest 16, but I should get how much wait time I should wait to get this money back. Okay, so this is a very, very important criteria. So all this report should have all this information for each and every line item, and typically we give this, and in this they will select, okay, so I'm getting the maximum benefit. If you see in the payback is lowest, is payback is power distribution within 7 months, and some could be your billing. Okay, I'm getting 1 month, I'm getting the benefit, I'm getting 11 lakh rupees if I do investment of only 6,000 rupees, for example. Okay, so they will go for quick wins. These are called quick wins, like kitchens. I'm getting savings of 3,000 rupees, okay, without any investment, for example. So like that you can see. So finally the decision maker who want to invest the money, or the customers, or maybe the management, okay, so they will decide that yes, this is a list of consideration. So totally, if based on this audit, the total investment will be 142 lakhs, and finally the savings coming is what you call 23 lakhs, and typically in the 74 total investment is 308. Okay, and savings is 174. So that means in 21 months he will get money of complete savings of 174. The cost savings has been achieved by this particular customer. Okay, and if you see the right side here, you can see in terms of energy consumption you need to calculate. Okay, that means how much is in terms of energy consumption happens in terms of energy units. Sometimes this can be non-electrical also, like HST fuel consumption also. So this also we can capture as a part of separately. Okay, now I'll take an interesting exercise for you. I'll take a pause here, maybe 5 minutes pause. So just one example here. So in this exercise is basically you can put your answers in the chat box. So the typical value in 5 minutes you can calculate. So here there is one facility or a particular building. So it has a fluorescent lamp of almost like a number of lamps are almost like 2070. Okay, weightage is 120, and wattage is almost like 248 kilowatt, and running for 10 hours. Okay, and what will be the calculation based on the audits, how the values are coming. So if this facility is running for 365 days for 10 hours working, and LED they are replacing with 10 watts. Okay, instead of 120 watts fluorescent lamps, so they're replacing with 10 watts. Okay, and investment of LED is almost 300 rupees per lamp if you take. So how much will be the benefit? So this is how the assumption happen. So we can see the number of lights, quantity is 10, the wattage is 10. Okay, then total wattage will be kilowatt here. So you can see the reduction happen here in terms of savings is almost like 11 kilowatt per day. Okay, and working hour is 365 days. Okay, and energy savings per month is almost will be 4,000 units they can save, and energy charge if it's 8 rupees, the total investment for monetary benefit is 32,120, and the investment is, for example, for at the rate of 300 rupees, 10 lamps will become 3,000 rupees. So total payback will be almost like a 1 month period. Okay, so this is how we need to calculate the what do you call the typically the assessment happen like this. So we should know how many lights. So for example, all the lights need not be replaced. For example, like because of lux level, the quantity of the lamps can be instead of 20, 70, it can be maybe 100 or maybe 10 or maybe 20, depending on the lights. Because so this example we recommending only 10. Okay, so that means with the 10 we get high LED lamps, we are able to get the same lux level, and accordingly this recommendation happens. Okay, so like that we can do calculations, and that's how we calculate the payback period. So payback period is basically your investment divided by your monetary savings. So in this case, monetary savings are very high, and investment is slightly low. So like that we can calculate your payback for a typical for 1 year. We should calculate the energy savings for always for annual for 1 year period actually. Okay. Okay, so I'll show you one typical energy audit report before I go to next topic of digitization. You are able to see my desktop with the report?
Yes, we are able to see.
Yeah, okay. Thanks. Okay, so this is one example of audit report where we do for a typical customer. So this is beverages industry. Okay, so here all this thank you message will be. So these are the contents should be available in the report. Okay, for example, here you can see there will be introduction summary will be there. Then these are the highlights of this particular facility. What are the proposed energy conservation measures? Means what are the ideas you observed? What are the ideas you observed as a part of the audits we should capture here? Then what is the energy cost benefits or cost analysis we should prepare here? Then you should give summary of the energy conservation measures. Okay, so how much? What are the list of conservation measures you should give the here? Then what is your annual energy consumption? Then specific energy consumption comparison or energy consumption breakup. Then what are the different type of energy conservation measures? All these are very, very important to submit in the report. Okay. Okay, so if you see come details here, I'll skip all these slides. Okay, so this is how the data comes here. So yes, okay, so you can see here total annual energy consumption. So it can be, sorry, yeah, it can be in Indian rupees also. Yeah, so typically the annual savings value, then investment figures, then payback. So this will be high level executive summary, because when you present this report, the senior executive members, they will not go into technical details. So they would like to see only high level summary report in one page or one slide. Okay, what is my savings, what is the investment, what is the payback, and what is the quick what you call in terms of summary. So this is a summary of this particular audit report which you present, you need to prepare accordingly. So this facility has an energy consumption of almost like 33 lakhs units per annum. Then FO is basically a furnace oil. So they're using furnace oil as a what you call fuel for their maybe boilers. Then electricity bill, what is electricity bill, then FO cost and energy cost. Then what is the impact on the reduction? Okay, so in this reduction, we recommended almost like a 17% annual energy reduction of energy cost, and fuel cost is almost like 29%. We are recommended reduction. So you can see huge reduction. Percentage of reduction is coming, average is coming 28% in terms of average cost benefits here analysis. So this is a summary which will be really make your end users or customers or maybe your management will happy. Okay, wow, this looks to be 28% huge saving cost point of view. Normally we don't get this much huge nowadays, because earlier days used to get. Nowadays people are having a lot of awareness of energy energy cost reduction and benefits and all. So yes, so more the people have awareness, the chances of getting high numbers are very, very difficult actually. Okay, so this is some analysis of the industrial environment analysis. So I'll show you energy conservation measures, how we do the conservation measures. Okay, so this is how the details should be prepared. Okay, so this is the first benefit example I'll take you, like how to reduce the contract demand of the particular facility. So this plant facility building has a contract demand of 1250 kVA, but the maximum they are using only 877. Okay, so I was telling you that in energy bill there are two parameters. One is your energy consumption kWh units per month, whatever happens. Like in your house, you get energy bills. Initial reading, final reading, and finally you'll get energy consumption, then cost. That's for house. When you go to industry, there's something called contract demand. Contract demand is basically like your what you call demand charges based on kVA you need to pay. So typically it becomes 75 rupees to maybe sometime 100 rupees will be there per kVA value. Okay, sometime to 175 also certain states, depending on state to state it varies. So here what we recommended here is that this 1250 kVA has to be reduced to 877. That means they're paying the maximum recorded demand is only minimum only 938. Okay, that means from 938 we are trying to recommend them to reduce by another 75 kVA, because the facility is running only 877 kVA. Okay, and they should pay 75% demand. Okay, minimum contract demand is this much. That means they are paying unnecessary extra 75 kVA they are paying to the government. Okay, knowingly or unknowingly. And so they just need to go back to the electricity board, tell that okay, instead of using 1250 kVA, we are trying to reduce it to maybe 938 kVA, so that within the band of what you call minimum demand it happens, so that you can get a savings of almost 75 kVA. So if I multiply 75 kVA into certain kVA rates, so we can get almost like this much of dollars, $1,000 you can save money without any investment. So idea is that without investment we can get this kind of savings. Similarly, I'll go to the next is optimizing the cooling loads, where okay, this will be very difficult for the students' point of view. Okay, I'll just give you example like this on how the reports need to be made. So, okay, so here main important is we should give the annual savings in terms of energy consumption. This parameter is very important. Energy consumption, there is a cost investment for the savings, and these are the investment figure. That means to get the savings sometime or most of times you need investment, some expenses required. Okay, and very few, rarely we get energy savings without any investment we can do sometimes. So there are three columns here: annual in terms of KWH, then cost benefit in terms of monetary benefit in terms of rupees or cost. Okay, then investments, then your payback. Okay, so this is how the summary goes, and finally we should see overall. Okay, so this payback is coming all with less than 6 months period, whatever 1 to 5. And the next category we need to categorize between 6 months to 12 months. Okay, for example, very interesting power factor benefit here is that you can see the low power factor is 0.96 and capacitors have failed. Okay, and they need to install the controller and make it improved 0.99. So here what happened, the energy savings less, but cost benefit is there and investment also required, and finally they'll be getting this money for 11 months. So the investment of this particular controller and improving the power factor, they can get the money back in 11 months, which is fine and which is very attractive from the finance point of view in terms of NPV or in terms of IRR values. So these are very, very attractive in terms of energy conservation measures. Okay, so I'll not go into detail because it will be heavy for you to go technical point of view. The idea is that we should categorize the projects in different paybacks. You can see 13 months to 24 months payback. Okay, more than 10 you can see comes under this category. So this will not be so much attractive to the management point of view, but it's good to know. And yes, sometimes the savings cost benefit is very, very high. For example, here you can see 172K US dollars. So you can get here. So the investment is 90 rupees, $90 or $90 approximately 90K. So you can see the cost benefit is 14 payback period. So this is very, very attractive because the cost savings huge. So they can still qualify for this kind of projects for implementation. And lastly comes more than 24 months. So yes, cost saving is very low, but payback is very, very high, not attractive from the management point of view or customer or end user point of view. Okay, so finally we should give the overall summary. Yes, so total cost saving, energy consumption is this much of energy consumption can be reduced. Okay, this is the energy consumption reduction, and this is the investment in terms of what are the currency. It can be US dollars or it can be Indian rupees, or and this is the INR in terms of in terms of investment. This is a investment value. This is a saving, and finally what is the payback. So yes, this particular phase payback, complete overall payback is almost like 10 months. Okay, which is very, very good. But if they implement, but the investment is very, very high. So again, the management or customers will think that, okay, do you really need to invest this much of money to get the savings? All those questions will come. Then they'll go and qualify. Maybe out of 14 projects, they will do first 5, maybe next 5, then again the next 5. So step by step they go implement, and finally the results are being monitored. Okay, so then we go into detailed data capturing. You can see here energy consumption of every month on month you should capture. So what is the month of energy consumption data? Then what is the energy consumption per month? Then you can see what is the fuel consumption, what is the particular, this is a beer manufacturing company, breweries company actually. So you can see how much kiloliters of beer is being produced here, and what is the specific energy. That means to produce 1 kiloliter of a particular product, maybe beer here, for example. So you can see how much energy consumption happens, kiloliters also. Okay, so like that we can do the analysis. Then we can prepare the KWH per this is called specific energy consumption, or to produce certain product produced in the industry, how much power consumption happens to produce such energy. Okay, so finally it hits your the raw material cost, or not raw material, what you call overall production cost basically. Okay, so the production cost, one of the parameters important is the energy cost. Okay, so raw material cost plus energy cost becomes a total production cost, and finally this helps to really know how to really optimize the cost by reducing your energy consumption. Is very, very important. These graphs help us to really know by reducing, yes, your energy consumption can be reduced. It will help us improving the profitability of the companies in terms of production area. Okay, so these kind of pie charts are very important to know who is your major consumption. So if you see in this particular industry, refrigeration takes almost like 46% of the energy is being consumed by refrigeration. Then they have brew house. Okay, then you can see bottling hall is the third one major. then air compressor 6%, so water treatment plant 3%. So like that we should do pie chart. So major coming is that yes, the refrigeration, if they do improvement, almost 46% of the energy consumption happening here is refrigeration. So normally we target this area as well as your bottling hall. So these are the areas when we targeted, and finally we get the maximum cost benefit comes under this category. And yeah, that's how this pie chart helps us to know the in terms of energy patterns. Okay, then we go to detailed energy audit. For example, like power factor improvement, we discussed how to improve the power factor. Okay, so you can see here by installing the power factor, what is the present scenario. Okay, you can see here what is the present scenario. So the present scenario is this much of demand, this much of contract demand improving. So power factor is very low. Now what we are recommending is improve the power factor to 0.99. Your KVR reduction will require is only 130 KVR. The annual cost benefit is 2.43. These are all simple calculations. We can do very easy. Simple electrical engineering calculations we can do here, and we can get this done. Calculation can be done. Okay, so then the contract demand. So this is another way of getting the calculation. So we need to prepare all these reports should be available, like details should be available in the report. Okay, because telling that okay, this much of cost benefit, nobody will listen. So okay, they'll ask you, give me details, give me the calculation details. They'll go and study details. Yes, it's really happening or not. This calculation is really right or wrong. So they will validate thoroughly, and then only the decision comes for the investment point of view. Okay, so this is for the topic of energy audit. Okay, now I'll go to second part, which is very interesting topic for energy, called energy digitization program. Okay. So any questions or okay? So I'll just conclude this. Then we'll have Q&A. Yes, sorry. Yeah. Okay. Second topic is digitization programs. Okay. So now the world, we are in 2022. Okay, and the world has really evolved the last 20 years. Okay. So the traditional way of energy audit, yes, it is going to be becoming slowly legacy, and step by step. Yes, there are many companies still or many industries still going for energy audits, but the world has really moved towards what you call digitization program. That means everything want to be digital. They want to see the data in your mobile phones, or maybe through your internet, maybe your through your iPad. Okay, so these are the world is moved now. So the world last 10 years, especially last 10 years, we see a lot of revolution happening in the industry. So especially for the college students like you, when you come out after maybe next 3-4 years down the line, so you can see a lot of buzzwords in the market. So I'm going to take you next 4 years, what's going to happen when you come out of this particular college. Okay, so I'll start with what is the revolution happened. Okay, so if you see the revolution happened here is so the first water and steam production happened. Okay, so that is called in 1800. You can see the first industrial revolution happened in the 1784. Okay, where your water and steam is produced, and the production facilities or factories are operated only by water and steam production. Okay, there is no electrical power at that time. Okay, so steam energy is used for running the factories, and machines are operated by these water and steam energies. Okay, now slowly the world evolved in somewhere around 1870. Okay, so you can see the electricity started, production started happening here. So electricity started produced somewhere in 1870. Okay, and you can see a lot of machineries or what you call production activities started. Mass what you call labor production started in somewhere in 1900, early 1900s. You can see here this is started. Okay, somewhere in 1969, the world has started moving towards IT. Okay, you can see a lot of automated controllers, your PLC based systems, or various different kind of controllers started coming in the market. Okay, and this is called third revolution of industrial revolution, called industrial without IT. So little bit slowly IT started, programmable logics controller started, microprocessor based concept started somewhere here in 1969 onwards. Okay, so industry start moving from what you call slowly evolved into the what you call in terms of programmable logic controllers. Okay, so this is called third revolution of industrial revolution that started. Okay, then now presently we are in the fourth revolution. So that is called industry 4.0. You can see a lot of buzzwords if you go to internet, Google, if you do search. Yes, industry 4.0 is a buzzword. Okay, it's called IoT also, Internet of Things. You can see words. Okay, so world has really moved, and we are in the IoT is that yes, IT system is started here, but IT is gone to the cloud technologies. That means I should be able to use Wi-Fi, I should be use mobile phones, I should be able to see what is my energy consumption pattern through my mobiles, laptops, or it can be anywhere. So I should sit here and able to see what is my building or what is my house, how much energy consumption. I should be able to sit from my wherever I'm traveling, maybe in the bus or metro trains or anywhere. Yes, we should be able to see the data. Okay, so this is a revolution started now, and you are getting evolved more and more. We're getting evolved as we go into the system. So what has changed really is that yes, the mobility is very, very important. Mobile phones has been started now. Every person nowadays has a mobile phones in the market, so they want to see the data in their mobile phones. Okay, so this is a very, very need of the hour. Okay, now next is the cloud base. Yes, they want to see through your cloud. Like you can see a lot of data are available in the cloud, like your maybe YouTube's or maybe your Facebook's or maybe all those things. So these are the various cloud-based platform. The data is available, and people want to see this one. And sensors. So there is a lot of revolution happened in the sensors. So sensors have become wireless. That means based on the Wi-Fi, based on your Zigbee communication protocols. So these are very, very popular in the market nowadays. That means without wired connectivity of the sensors, I will be getting the data into my various controllers, and from controllers it goes to internet, and internet to my mobile phones. Okay, so this will happen. And also the world has moved towards analytics. That means I should be able to get the data from these various sensors, from the various cloud-based system into analytics, and I should be able to predict my energy consumption, what will be my energy consumption or energy data. Okay, so energy data for my next month, for example, I should be able to predict my energy consumption data for next month. What will be my energy consumption data? Okay, so there's something called energy modeling. So that's also very, very interesting topic. You must be knowing. So maybe you can explore also. So we can, based on the energy modeling, based on the energy baseline modeling, we can predict what will be my energy consumption next month, next year, next 5 years. So we can do all kind of intelligence are available in the market, and this is also getting evolved, and this is all new generation happening in next few years. So lastly, cyber security. Yes, cyber threats are very, very common, and we should see how to improve the levels. Different levels are there. Yes, still this is also evolution happening in the next few days. So this is also very, very important, especially the people in the electronics and communication background. So we should focus on these 4 areas in coming days, where you can really, when you come out of this college, yes, you will be ready for industrial revolution to handle and catch the same speed as we are capturing in the market. Okay, so if you see the IoT platform, so you can see a lot of buzzwords here. You can see the words called industrial protocols. Okay, so if it is typically, there will be a lot of sensors. You can see here a lot of sensors like measuring instruments. You can see cameras. You can see gauges here, digital gauges. Okay, so there are various kind of communication options are there here. You can see here. So if you see here, if first is the various protocols also available. So for students in the communication or electronics and communication industry, yes, you can see, you should be knowing these buzzwords in coming days, something called Modbus, CAN bus, HART communication, Profibus, and also if you see wireless technologies, LoRa, Zigbee, Sigfox. Okay, so these are the few wireless and wired communication protocols we should be prepared. Okay, and we should know that how these sensors are generating the signals. Okay, because finally all the signals are again goes to energy management or energy digitization only. I'm taking this level. Okay, so all the data, whatever you're talking of, like energy consumption data, fuel consumption data, or maybe your pressure, maybe temperature, maybe flow, all these are different form of energy will be available in these sensors. Okay, and these sensors will go to a different controllers or gateways. Okay, so these gateways are basically collecting the data from the various sensors. Okay, so for example, this is a temperature sensor. So the temperature data I may get in terms of maybe in the Modbus communication. Okay, that is typically RS485 communication, or sometimes it can be a pulse output. Sometimes it can be a milliamps output, 4 to 20 milliamps signal output. Okay, so these are the outputs. There are different type of outputs can come here. Depending on the different type of outputs, I should be able to design my controllers for a capture inputs towards input. That means this output will get connected to this particular input here, and the data will capture in this particular. I show you architecture in the next slide, how we can get connectivity happens here. Okay, so these controls will help us to really get the data into a different form, and from there we can convert to the various platform which are required for IoT. So IoT popularly presently market is available is TCP/IP is a very, very commonly used IoT platform. So if you see any industry, most of places you can see a TCP/IP based network will be available, LAN network, basically LAN network. Okay, so the data will be captured here. We will pass through your various security guidelines. The data management will be there. That means you should know how the data need to be managed. So again, you should know the database used for the different application. It can be SQL Server database. It can be Oracle. It can be MySQL database. Okay, so there are different type of database arrangements are there. And storage, again, you should have the hard disk servers availability. Okay, so you should plan your storage data. Sometime you can be on-site storage in a server PC. Sometime it be cloud-based storage. Okay, and finally you should see how to support the analytics. Okay, getting data is very easy nowadays. Getting data is just a beginning. So once you store the data, then you should see how to make analytics and how to bring the value in terms of artificial intelligence, how to make the predictive analysis, how to help the people to bring the energy consumption reduction, how to help the customers to bring the carbon emission reduction. All this comes from the analytics actually. Okay, so there are something called apps and services where the analytics will help here, where the data gets captured in the various software, the dashboards, your reports, trend charts. I'll show you live demo of this particular application here. How we do this, I'll take 2 minutes and show you live demo. And finally, there will be people, and some people will analyze this data through mobile phones. And finally, yes, we bring the value in terms of analytics and services comes as a part of this particular service model. Yeah. Okay. So finally, the data can be stored in your IoT, like Microsoft Azure, Amazon Web Services. These are the very popular where the data can be stored. Data storage happens. Okay. So this is how the world is evolving, and moment you come out of the your studies or in industries, you can see all these kind of buzzwords will be very common for you. The data is stored in my Microsoft Azure, Amazon. Finally, the data goes via controller and via your storage various servers. Very important actually. Okay, so in how we normally industry evolves here is that if you see here, these are the sensors. So there are different type of sensors. You can see here very high level here. So these are the power meters and various flow meters which will be used for energy management applications here. Okay, there will be softwares which will be used for energy management application. That means the data will be captured in the software. So the data from this system will go via Profibus or Modbus or maybe CAN bus or maybe any protocol. The data will go into this particular system, and these are the various assets will be there in the customer's premises. Okay, there will be a transformer here. There will be a genset. There will be your chillers, air conditioning systems, then equipments and cooling towers. So these are various assets in a very high level. You can just assume here. These assets will have these kind of sensors or instruments will be available on these sensors. Okay, now these sensors will get a lot of data. I can see the energy data here. Okay, if I zoom here a little bit, I can see the energy data. You can see here live data. So you can see live data, energy meter data. So this data will be keep on coming in the meter. Now this data we bring into the software, and we connect via networking protocols here and get the data into the system. Okay, and this system will be like a server based system. That means there will be PC based system. The desktop application will be there, and the data will keep on capturing. I'll show you live demo of this particular platform. Okay, this platform I'll show you live demo maybe 5-10 minutes by keeping the time. Next 5 minutes I'll try to close this. Yeah, so then we go to advanced level analytics. I was talking of apps and analytics where we analyze the data and help the customers to really energy optimization. So this is how we do the active. So this is 3 layer. So if industry they call edge computing layer, and this is called apps and analytics layer. So these are the 3 layers will be there in the IoT platform. Okay, so when you come out of come into the industry industry, okay, so you can see the people are using most on the edge computing layer or cloud layer or apps and analytical layer. So these are the buzzwords people will be using in the industry. So this is a very simple system. The data coming from the various sensors or connected products will come into the edge platform, and from it goes to cloud-based platform. Okay, so now these are the various things you require to from the, if you want to, for example, if you want to make your college, okay, or maybe your university, you want to make it energy efficient, sustainable, how you can plan. Okay, so typically we should see there are a few angles here. First thing, you should make your utilities. So utilities are basically your air conditioning system or maybe your water system, which is required for your colleges. You should see that how to make it more efficient here. Okay, so again we need to monitor the performance of this water consumption, your power consumption, your air conditioning systems, complete parameter like temperature, your flow, chilled water flow, power consumption, everything has to be monitored. Okay, similarly you should see from the power safety point of view. That means there should not be frequent tripping of your equipments. There should not be blackout. Suddenly power fail should not happen frequently in your facility or maybe in your residence apartments or maybe wherever you are having a project. Then we should see from power quality point of view, there should not be frequent harmonics related issues, all those things. And finally, we should see that whether this facility has a renewable energy. Okay, you can see these are the renewable energy, that means solar. You can try to generate the power, or maybe your the heat which comes from the solar. You can try to use it for it can be for energy generation, it can be for your hot water generation, it can be for any application you can use for this kind of solar. So we can see the renewable energies are used in the facility, and you can, there's something called microgrid concept is coming very popular, where the data coming from the different sources, like your EB source, your renewables, it can be your genset, it can be thermal plants. So there are many applications are getting very popular. It's called microgrid. That means you are creating a grid within your own factory or maybe within your campus. Okay. So this also will help to improve the carbon footprint. Finally, energy management, yes, and smart buildings. So these are how the typically the energy efficient facilities or people are planning actually. Okay. Now, how this benefits energy digitization going to help the various customers or users? Okay. The first benefit is into improving the efficiency. Again, we are coming back to energy saving, energy digitization here. Okay. How to save money, how to save energy, how to prepare the energy action planning. That means, again, energy conservation measures. So once you digitize, you'll get a lot of data where we can analyze and find some energy conservation measures. Okay. So this will become a real-time basis energy article efficiency or energy improving the energy conservation measures. Okay. Secondly, we're trying to improve the maintenance. If there is frequent failure happening in your facility, or maybe your apartments, or maybe your wherever the place you do audits, we're trying to see how to remove or mitigate your failures as less as possible. How to make condition-based maintenance. Before the failure happens, you should be able to predict. Okay, so those kind of things can be happen. Smart algorithms can be built in the system. So this is also very valuable, which have capabilities. That means before a failure happens, yes, I can predict the voltage is what you call, the power is going to trip because of my what you call for example DG set. Okay, if there is no fuel, before the fuel gets over, I can predict and tell that okay, the DG set is going to trip in a few minutes in my apartment. Okay, so like that you can build some reactive condition based maintenance can be built here. Then we are trying to see how to see frequent your business continuity. That means the business should be running smoothly. There should not be any disruption. You should see from the electrical safety also. Sometimes you can see in many hospitals, especially in hospitals, you can see many patients died because of poor electrical safety challenges. Okay, so we need to see that the electrical reliability is very important. So once you do energy digitization, you will know the harmonics level, you will know the power quality level, you can see what is the earth to neutral leakage current happening. We can know that how safe is this particular facility. Okay, so there are many hospitals that recently have fire. All are safety related with electrical safety, which has been neglected by the many the hospitals, which looks very sad by default. So yes, once you do digitization, yes, we can see and predict. Yes, there's some safety challenges can be eliminated, and we can see that happening. And finally, sustainability goals. Again, we know the talking point is the carbon emission reduction. As our chairman was telling that yes, carbon emission is one of the talking point. Especially government of India has taken an initiative to reduce carbon neutral by 2070. So yes, this once you do energy digitization, yes, we are going towards that particular goal of carbon neutrality. So you can make your own college campuses can be carbon neutral campus in coming days. You can see how I'll show you how we can do this carbon neutral also for your facility. The couple of slides are there. I'll take another 5 more minutes. Okay, so and finally there is an approach when you do this kind of program. So we call 5-step energy management approach actually. Okay, so first we identify what are the utilities or energy usage happening, what are the key KPIs we need to define for your equipments. Okay, that means for transformer there will be some key performance indicators. Okay, similarly gensets, similarly your air conditioning system, similarly your lighting loads. So there will be set of performance KPIs. Okay, key performance indicators, the short form of KPIs. Then we need to install the sensors. So sensors like your energy meters, it can be your lux level meters, it can be your flow meters for your chilled water flow, it can be temperature for your air conditioning systems. Okay, so we need to conduct a survey, we identify, then we digitize. That means we get the data from all the sources, we bring into the one platform. I'll show you architecture how we do this also. Okay, then we analyze the data, we set the baseline KPIs, we analyze the data for energy reduction and carbon reduction. Advisory services will happen here. Then we optimize, really work into the implement some changes, optimize, we validate the list of energy conservation measures. We validate here again. And finally, yes, we sustain. That means we do the measurement every month on month. We need to measure the savings are really happened or not after the stage number 4 is completed. So we validate the savings. We set the baseline. Yes, the savings has happened. Okay, because this is the most difficult part happens in the energy program. That means convincing the finance people or maybe the senior management telling that my energy savings is happening, because they'll ask you a lot of questions and a lot of data we need to prepare. So this normally this kind of initiatives helps to know the end user how to really quantify the savings and give the calculation data based on the operating hours, based on your savings calculation you need to present. So this will help us to really, so this is how the program goes actually. Okay, finally, this is how the architecture happens for a typical industrial environment. You can see here. So this is a Modbus. I was talking of Modbus of various protocols used in the different industries. You can see here. So these are the various assets of the different customers will be available. So for buildings, you'll have more air conditioning systems. Similarly, for industry, you'll have boilers and compressors and production areas. And this is LPG yard. Okay, so these are the various instruments. You can see a variable speed drive used for a motor application to reduce the speed of a motor. For a pump also they're using VFDs are used for pumps application also. You can see energy meters for monitoring the energy data. Okay, here you can see flow meter data for monitoring your water consumption, air consumption, fuel consumption, steam consumption. So this data will go via flow meters into the particular gateway. Okay, these are controllers basically. From the controller, it goes to Ethernet network or IP backbone. Okay, so this is the IP backbone for a typical IoT. So most of the IP backbones are available in the most of industries or colleges or in maybe large buildings. Okay, so IP backbones are very, very common. Okay, so all the internets are operating the IP backbone basically. So this will go to a centralized edge layer platform. Okay, edge layer platform, the data will be available. From there, it goes to advisory services where the data gets analyzed. So very important, this data has to go and store in the SQL Server database also. So if you, when you go for this kind of projects, yes, we should see that you become expert of SQL Server database also. That means as a student, not only from analytical point of view, you should be expert in the database management also to really manage the data, work on the analytics, make the different type of dashboards. All these things are very, very important to know SQL Server database. Okay, then we analyze the data as a typical energy audit. How we do the energy audit, we do the measurement. Yes, there will be quick wins. Once you get the data into the software systems, you can see there's opportunity to reduce some temperature settings. Okay, but like for example, when you do this kind of digitization, for example, your AHU, one of the AHU, your temperature setting is 20 degrees, for example. So some operators set 20 degrees, but typically the temperature for a typical office buildings or it should be around 23 degrees. So on the system, we came to know that yes, the temperature is kept very low, and 1 degree is almost like 2 to 3% savings can happen. So just increase the temperature from 20 degrees to 23 degrees. 3 degrees is almost like 6 to 7% energy savings can hit you by only without any investments. Similarly, flow optimization. So the building is very vacant, but chillers are running full blown with high flow rate. So we can reduce the flow rate of the chiller, and accordingly your chilled water flow optimization happens. So energy saving happens. Similarly, pressure. So there are different categories here. Category A will help you to get quick wins basically. Category B will be a routine maintenance expenses. There will be some cleaning has to be done, some maintenance activity has to be done, some leakages are happening, we need to be arrested. So this will give again energy conservation measures here. Okay, then comes category C, where the medium level investment need to be done by the customers. For example, throttling. So throttling of a pump happening, we need to install a VFDs, for example. Similarly, poor installation in the chilled water line, that cooled water is exposed by the surroundings, should be protected with the insulation. Otherwise, your ambient temperature is going to reduce the temperature, and will make the chiller to work hard more to maintain the temperature. So these are the various category A, B, C, which helps to really categorize the energy savings. Okay, and again, the paybacks has to be calculated accordingly, will come as a typical payback period. Okay, so finally, yes, all this leads to your carbon and energy reduction neutrality. Okay, so for example, this is how we design the solutions. For example, like buildings, we should have set of KPIs, cooling set of KPIs. Then these are the equipments. Okay, then we go into the various different loads, buildings, heating loads, cooling loads, compressed air, then process area. So we need to have set of KPIs. KPI means by seeing this data, I should be knowing that whether this chillers are running efficient or not. Now, if you go to any chiller plant, people will see that, okay, chillers are running, and you can see some ammeter, voltmeter, or some energy data, but people doesn't know this running efficiently or not. Okay, so normally we have set of KPIs will help to really know that by seeing the data, okay, the savings chillers are happening efficiently within operating limits. Okay. Then your renewables helps to reduce this one. And finally, you can see here carbon neutrality happens here. I'll show you one example here. I'll put in zoom. Okay. So if you see here, baseline of carbon, this is the carbon emission happens typically by burning the of energy. Okay, so when you burn energy, it can be in-house energy, it can be energy can be from the thermal plant. Okay, that means you're buying power from the grid or from the utilities or maybe from KPTCL. Okay, so this is how the energy carbon emission happens, and because of the various increase in occupancy or maybe production, carbon emission increases. Okay, and more the production happens, again further increase in carbon emission happens. Okay, from energy services, you can see here process efficiency and utility efficiency. By doing energy audit service or maybe energy digitization program, okay, you can see that the energy, okay, you can see here carbon slightly get reduced here. Up to certain limit, yes, we can do. We cannot go for completely carbon neutral by only by energy audit services. So there need to be done from renewables. Okay, if you see like solar energy, usage of solar energy, or sometime power purchases, that means we can buy the renewable energy from the third parties also. Nowadays in India, after 2003 Energy Conservation Act, the market is open to buy the power from the, not only from the government power generation, you can buy power from the private players also. Okay, and this can help you to know the power can be renewable power. I can buy from the, I can buy solar from maybe, for example, like Jindal, or maybe by Adani Group, or maybe anybody who's producing the solar. So we can buy the power from them, and we can use as a solar or it can be wind energy. So like that, we can help to really offset the carbon emission happening here. And finally, we are trying to reach the carbon neutral by end of this year. So this is what the government of India is trying to do for complete India. So now this is not mandatory, but slowly it also gets mandatory. Every industries or every building has to work on this in next 50 years. Okay, so that by 2070 the country can be a complete carbon neutral. And so you can see more focus is on the renewables coming. More and more renewable energy is must for India to really make carbon neutral. And yes, energy efficiency, energy audits can bring up to certain level of energy reduction, but definitely it cannot do for carbon neutrality point of view. So this is how the system goes, and this is how we drive in industries to make carbon neutral with both energy efficiency, or through energy audit process, or maybe energy digitization process, or maybe through renewable energy various applications. Okay, so this is how the pledges happens for a government of India. Just to give just a basic knowledge, so this is what country has promised to the nation, to the globally, that we want to become a carbon neutral by 2070. You can see India will achieve the net zero by 2070. So this is how the journey starts to do. And again, you can see renewable energy is very, very important to reach that level. So India will meet energy by 2030. India will have a lot of renewable energies focus, and fossil fuel we need to reduce. Okay, we should use fossil fuel as low as possible. That means we need to increase non-fossil fuel based capacity is very, very important. Okay, so this is how the world is moving, and we want to really become a carbon neutral end of the session. Okay, and if you see the what is carbon generation happening, you can see here examples. So if okay, if normally in houses we buy power from the government, okay, that means utility power. Okay, the power purchase comes from the various electricity. So we create a carbon scope 2 emission happens because of the carbon energy we are buying from the utilities or grid. Okay, so this is we call indirect emission from the purchased energy. So this is how this happens. Now there will be scenario that is called scope 2. No, pink color is called scope 2. Scope 1 is basically the energy which has been burnt inside your campus. For example, genset, when generator operates, it creates a lot of fuel is being burnt, like diesel is being burnt. Similarly, boiler, similarly furnaces in industries. Okay, so all this will lead to your carbon fuel, fossil fuel burning. Okay, so this comes under scope 2 category. Okay, and scope 3 is basically your employee travels, or what you call your campus buses, for example. So campus buses for students, the fuel is burnt because of the transport arrangements done by the colleges, or maybe offices, or maybe by industries. Okay, so also the waste management, also the travel happening for your business trips by the employees of the respective institution. Okay, so all this leads to your carbon emission 3. If you see here, you can see CO2, SF6. These are the various fuel which creates environment pollution. And finally, the carbon emission, we are trying trying to reduce this as low as happening, this carbon emission happening, which can really create problems in next 50 years to the next generation coming up here. So yes, this is a journey will help the benefits to the most of the industries. Okay, so yeah, this is also one of the interesting slide where we can work for carbon neutrality. So if we are here, we are trying to reduce the carbon emission here, and this is called net zero carbon here. And if you further go down, you can see net negative carbon emission or carbon positive. You can tell carbon positive here. So this is how the journey goes step by step. So all companies are trying to reduce energy consumption as well as carbon emission gradually. And at this point, you can see a lot of announcement happening in the newspaper. I'm going to become a carbon neutral by 2050 or maybe 2030 and all. So this is how the journey starts, and this is how the carbon decarbonization happens by reducing the energy reduction as well as carbon burning. Yes. Okay, I'll stop here, and this is my last slide, but I'll show you, want to show a quick demo. Maybe I'll take 2 more minutes to close before I close here. Okay, this is a live demo. I'm showing one live of how the data from digitization happens here. So if you see here example, I am able to see my energy consumption data, live data. So this is a dashboard of a software which is running for a digitization program. So here you can see the live data. What is my energy consumption last month versus this month? And if I want to change consumption last week versus this week, if I click here, I should be able to know what is the last week versus this week consumption. Okay, and if I want to know what is my power consumption in hourly pattern. So this is also very beautiful analytics. You can see here, this is how the live energy digitization benefits is going to happen. Okay, so it's almost like similar to energy audit itself, like but energy audit, we need to measure the data with the power analyzers and all. So here the world has evolved. So you can see yesterday my consumption is this much and today is this my consumption. You can see a comparison. Okay, so this is live data coming, and we can see it's slightly increase, and you can see today is slightly lesser compared to yesterday. The usage is slightly less here. You can see a live beautifully. So this is how we bring the various values. Similarly, we are talking of electricity power consumption here. Similar water usage. So water also very important usage. You can see in terms of meter cube, what is the water usage happening. So we can see monitor the performance of water also here. So you can compare the water usage hourly pattern. Okay, so whenever the water is used, you can see what is the today there is no usage of water. So like that, you can see how different kind of analytics can be happening here. So okay, similar cost benefit. Yes, we are talking of cost benefit of energy cost here. So you can see live cost calculation. So we know the tariff of the water or tariff of the energy, electricity or fuel. We know the consumption data coming from the metering. So finally, you can see how much is the water consumption, fuel consumption. Everything can be seen here live actually. Okay, so yeah, then also I'll show one interesting graph here. Okay, so people would like to see what happened yesterday night in terms of energy consumption data, for example. Okay, okay, so here you can see this kind of profiles are available in the digitization program. So you can see here in the building, so water usage. So as you can see here, the building consumption water in the night, sorry, after 2 p.m. is something around 1.3 meter cube. Okay, so you can see here in the night time also you can see the water usage happening in the very excessive water usage. So like this is how we can see the opportunity to some optimization can be done here. So you can see 10:15 p.m. Early morning 1 a.m. 10:45 a.m. You can see 7 a.m. So you can see some water usage happening in the night, midnight 2 a.m. 5 a.m. and all. So you can see. So this is how we can get the analytics here. This cannot be captured via energy audits. Okay. So in the energy audit, what happened? The measurement, whatever you that particular period of time, yes, you can take some assumptions here. But in the energy digitization, what happens is you are going to see the trend analysis of historical data. I can see what happened yesterday night, what happened 2 days before, what happened a few days before. So here I can see last 60 days. If I click here, last 24 hours, yes, we can see what is the trend analysis. So you know exactly what happened in the night at 2 a.m. You can see here. So excess water usage happened in the facility. Okay, so this is how the analytics can bring the value, and we can tell that okay, tomorrow also same time should not this kind of usage should be eliminated unless there is some real reason between the leak. It can be water leakage or it can be some misuse of water happening in the midnight in the facility. So this one we can agree. Yes, office started here and the consumption users are there, but definitely between 12 a.m. to 3 a.m. yes, we can see that kind of abnormal usage, water of usage can be eliminated. Yes. Okay, so I'm going to stop here and we'll open the question. I think I exceeded time here. Sorry.
If the chair can open the session for Q&A from the students.
Yes.
Students, if you have any questions, you can put it in the chat window. Students, if you have any questions, you can put it in the chat window. So, ma'am has raised a question. For small consumers like residential premises, what conservation methods are proposed that will be cost effective?
Okay,
Sir,
so yeah, okay. So if you see in a residential premises, so your major consumption comes from the one is a geyser, okay. Second is your refrigerator system, okay, and the third could be lightings, okay. So these are the three major will be there, and maybe air conditioning will be there very few cases. So yes, the first benefit will be conservation measure you should focus on the what type of your refrigeration what you call rating of that particular star rating. So if you see the your electrical geysers, okay, so the government of India under Bureau of Energy Efficiency Standards, so they have given a labeling or what you call energy certification with rating star 1, 2, 3, 4, 5. Okay, so you should use you should check whether your geysers are of what type of rating or star rating. Is it label 1, 2, 3, 4, 5? 1 is most inefficient and 5 is the most efficient. So unless these ratings are not done by the Bureau of Energy Efficiency Standards, you should not use those geysers. So if you see last 5 years, you can see all the geysers are, you can see one sticker will be there on Bureau of Energy Efficiency, what type of star ratings are available. Okay. Secondly, for refrigeration also, so which are the refrigeration you are using? Yes, we have these kind of ratings are very important. So that means this efficient, this star rating indicates that this consumption of this particular is based on the energy efficiency concept and is consumed very, very low. Okay, that's very important. Secondly, this the temperature settings of the refrigeration, you should see that your freezers doesn't keep at a very, very low minus temperature. You should keep optimum, maybe instead of minus 10, maybe you can keep it maybe -5 or maybe -2. There are different settings are available in the refrigeration, which will help you to slightly optimize your refrigeration, because refrigeration runs 24/7, 365 days in your houses. So which is major consumption. Similarly, geysers also, again, that there are settings available in the water temperature settings. So we can see that optimum temperature set in the geysers, and also the type of geysers you're using is star rated. And lightings, so lighting definitely should be LED. So you should see that if you're using fluorescent lamps or any filament lamps or bulbs in your houses, yes, you should replace with LED. Even though LED will be a little expensive now, but still your return of investment or your life cycle of that LED bulbs will be very, very high compared to your filament bulbs. So these are the three conservation measures I think you should focus within your houses. Yeah, that's my suggestion here. Then second comes is cyber security. Okay, one question: cyber security domain for energy audits. So cyber security doesn't come for energy audits; it comes for energy digitization program. Yes. So there are some standards called IEC standards are there for a different set of products, and there are level 1, 2, 3, 4 are there. So yes, cyber security standards complying to IEC standards has to be the products or the sensors or software should be a cyber security compliance. Okay, so yes, in industry, when you see the data sheet of that particular cyber security, this is important, but not for the energy audit point of view. Energy audit point of view, cyber security doesn't come because you are not connecting the energy instruments to the what you call the portable instruments. You are not connected to internet. But yes, when you go for digitization program, yes, cyber security will be the one of the criteria. Definitely the standards we need to check. The next question is sensor to integrate before project starts or baseline required. Yes, so normally sensors to be installed before the project starts, because once you connect the sensors, you will get some data, historical data you can capture, like maybe for 1 day or 2 days or maybe 1 week or 1 month data. So that will help you to set the baseline. Okay, so the baseline setting is based on your time of period. For example, you know the baseline load of night time, your load of the particular building, for example, or maybe your house, for example, you know that baseline of load may be definitely 1/3 or maybe 1/4 of the normal usage of the night power consumption. So that will help you to set the baseline for different time zones, time period. So yes, sensor installing before the project is very, very important to set the baseline. And there is another baseline which we can take as a baseline, can be taken based on your energy bill also. So normally in industry, when you do energy audits, so we take a baseline period of 20 previous year, basically like 2021, the January to December becomes a baseline year. So we are going to see the performance of your building or your house, okay, based on your last year bill. Okay, for example, if I want to tell that I saved energy, maybe 10% energy, so then there will be next question, what is the baseline? So definitely previous year, that is 2021 year will be baseline, and whatever the measurement you do for 2022 will become the what you call the comparison year for improving the baseline. Okay, so that is a question on the baseline. Then is it possible to make electricity wireless? So okay, so there is a okay, so electricity cannot be made wireless. Technology is still not evolved, but there are communications can be done through wireless. Communications are available, something called PLCC. Okay, so but not electricity is still not matured. That market still not reached that level actually. Yes. Then yeah, next question is carbon neutrality to be achieved by decreasing the carbon emission. Yes, so answer is the question is reverse actually. The carbon emission has to be done. That's why I showed you one chart, basically the reducing your carbon emission of your scope 1, scope 2, scope 3. So all these three things will finally lead to your carbon emission reduction. And once you reach carbon emission production as well as mitigation through renewable energy, okay, so it will become a carbon neutral. So there's a calculation need to be done. I showed you one rough chart last slide. Yes, it can be done through carbon emission reduction only, carbon neutrality. So next question is it possible to add filters to the chimney for carbon emitting factories so that we can extract carbon and chemicals? Yes, so there are not filters, there are something called what do you call flue gas reduction. Okay, the flue gas, what they do is the flue gas, whatever generating from the chimney, for example boiler, we pass through the economizer. Okay, we pass through the economizer. So what happens, the temperature of the chimney comes maybe 170 degree or maybe 200 degree, it goes via economizer. What happened, the economizer will pass through waters. So we pass the water through that economizer. So this heat produced from this chimney heats the water from the temperature of 30 degrees to maybe 70 degree or maybe 80 degree. So because of that, what happened, the temperature of the air, the flue gas air or the chimney reduces. Okay, when it passes through the cold water, the temperature becomes 170 to maybe it comes to maybe 150 or 140 or maybe 100 degree. So that will helps to reduce the chimney going out of the chimney to the environment. It becomes heavy, and finally we see that the chimneys as a flue gas or what you call the contents captured through a chemical separate out. So yes, the technologies are available, and we are trying to, in industry, all people are trying to install economizers and various heat recovery systems, which will help to reduce the chimneys from the different vent systems. Yes. Then how the home energy audit to be delivered and resulted? Yes. So okay, so delivered, first thing is you should make the measurement. So there should be a lot of data. You should capture the home audit. Delivered means first you should measure the data. First you should select what are the major loads in your house. Okay, definitely geysers, refrigeration, lighting. Then if there are pumps in your houses, like water pumps, you should see. Then yeah, so these are the major things which we can focus. We should see how many hours and what is the kilowatt of this load running. So by measuring the kilowatt or ampere, you can calculate the kilowatt or energy based on the kilowatt into operating hours. Helps you to know the what is the kWh per day or per month. You can calculate. From there we should know, okay, how to target whether this equipment is really efficiently running or not. Is the water pumps are overflowing the over tanks? For example, in many cases we see that the water pump overflows. There are two losses happens there. One is water leakage as well as your power consumption. Okay, so now normally there is something called auto level controllers available in the market. So people install the water level controller for your overhead tanks. So when the overhead tanks reaches the water level, it gives signal to your motor to switch off automatically. Okay, finally your the power consumption reduces as well as water overflow reduction. So yes, so finally they need to be delivered with some actions. That means some implementation should be done, and you should measure the data before and after. So once you prove that yes, before doing the audit, there was no level controller for the water pumps and water was overflowing. After you implemented, yes, the water flow is reduced and your pump reduction also happened. Finally, you should be able to calculation and should be able to submit the report separately. Next question is, how is the digitalization helpful? Okay, so digitalization helpful is a long term. Yes, you can see the efficiency of your equipment real time basis. Okay, one is the historical data. So there are big list is there. So I explained you 4 benefits here. One is in term improving the energy efficiency. The first thing is energy efficiency improvement. Second is in terms of maintenance. Okay, so for example, if the design of the example of, I'll take the same water pump in the overhead tank. Okay, with the design, I know that exactly the water level sensors are working properly, and what is the level of the water over my overhead tank. I can sit from my laptop or my mobile phone. I can know that, okay, water level in my overhead tank in my house is only 70%, 80%. Okay, so that will help me to really know that yes, how minutes or the pump has to run in my house to to send the water to the overhead tank, and accordingly we can see that is working properly or not. Okay.
Sridhar, I suggest, because I'm sure the students would not be used for such long sessions. I would suggest we put the questions on hold. And Anna has my contact and your contact as well. So Anna, if you can help us download these questions and send it to Sridhar Shenoy, we would reply back to you on the email, and that can address the doubts of the students. And the other part is, if you have any major doubts, Anna, your students can contact us, and we would be more than happy to explain it to the newer generation, millennium people. So we are more than happy to do it. So requesting, maybe we can bring Sridhar Shenoy's session to an end, and we can start the session of metric training and consulting group. The only request to the metric group is that let's not spend too much time on the organization profile. Rather, what is beneficial to the students is what we should be talking about, if it's fine. Yeah.
Yes, sir. Can you make Adinarayan sir as the host?
Sridhar Shenoy continue to be on the line, because I'm sure, the chair and the other people would like to thank you for your contribution. So I think that will happen at the last another 10 or 15 minutes of session, and till that time be on the line.
Yeah, sure. Thanks.
Before while in the process that Adinarayan gets into the PPT part and he's able to present it, I just have a word of a couple of sentence to communicate the students out here. Now, the session that our Sridhar Shenoy contributed is on a very high level. I'm happy. We would be happy even if 50% or 60% of the messages that you are able to grab is a great achievement, because these are things which are being, which will be to the level of people with 20 or 25 years of experience, and you are budding people. So it takes time for you to grasp all these informations. Now, what is important is, this is where, the idea of me bringing in Sridhar Shenoy and then, getting in the metric training and consultant group is to ensure that there is a stepping stone available for the students, for this subject. Now, there's a big difference between what the industry develops, or what the education institution develops, and what is the need of the industry. Now, to reduce or mitigate the difference between these two, you are the contributing organizations, the education institutions are the contributing organizations, and the industries are the using people. Now, to ensure that your institutions are making a good amount of people who are valuable to the industry, we are trying to put in a session which is a practical and theoretical session, which Adi Narayan will talk about. So that's the essence of this session. This might at max go for 10 minutes of time. Listen to this. It's a very important and very valuable session. This will make you industry ready when you are out of the college after about another 3 years of time. When you are out, it will make you industry ready. That's the message from my side. Adi, if you are ready, it's over to you.
So you can take over the session.
Imtiaz sir, will you be able to unmute
Hi.
Adi? I think he's on.
Yeah, right. Yes, it is enabled now. I hope I am audible.
Yeah, you are very much audible. Thank you.
Thank you, Sanju, for that heads up. The introduction which I wanted to give you already covered that. So I won't take more than say 10 minutes, including the Q&A if anything comes up. Okay, I have just made a small presentation, just 4 slides. So thanks to Dayanand Sagar Institute of Technology for giving us an opportunity to present this our offerings before your students. Thanks to Mr. Sridhar for a wonderful presentation. As Sanju said, it was, slide of some of them would have gone above your head, but I'm pretty happy to see the queries which has come up, and I hope those who have asked the questions are really shown the depth of understanding which we are able to appreciate that, and I feel the answers would have given you some clue. So what I would like to take you from this session is that I would like to look at this as a macro industry, wherein you feel that there are so many things in offer. So why not I get into this industry, because there are so many types of activities happening. There is electrical things, there are mechanical, there are electronics, there is automation, IoT. So it's a gamut of entire engineering built in together. So there is job opportunity for almost all the various engineering branches. So that is where we as industry partners, we as training partners to Schneider Electric, we try to connect you to these opportunities. So we introduce you these opportunities what are available in the industry. Since we are working with industries, we can provide you where you can get in. So we act as a conduit. As you can see in the picture, we are training partners for Schneider and also SMC, which is a pneumatic expert company. This is also a Japanese firm. And we are also working with the government on the various skilling activities like the Electronic Sector Skill Council of India and World Skills Academy. We are establishing, it will come up in another 3 months' time, wherein a lot of automation and electrical as well as pneumatic activities would be, training activities would be conducted. So we proudly say we are building management experts, we are building automation experts. So this is our training philosophy. As Sanju said, I won't spend too much on this, but I would like to explain to you, saying that we work on 4 pillars. One is on the contents, the training contents. Yes, our engineering colleges are working towards industry, making the contents ready to the industry. There are a lot of activities as per the national education policy, which the government is also making it. But presently, we understand there are some small gaps which are available in the current syllabus. So we try to bring in some contents which are relevant to the industry, and we teach you. We do regular assessments so that we are part of your learning journey. We monitor and track and tell you How do you move forward? We give you feedback, technology based. There is a learning management portal which we have, through which the learnings would happen. And once you are there, you have, you become an alumni of our learning management portal, and you can do lifelong learning. We give you snippets. We share you knowledge in a small, nutshell, and you can keep conducting. So these are the fundamental pillars. Our objective, our foundation is of understanding the industry and understanding you, the trainee, what gaps you have, how do we plug the gap. And our objective is to enhance employability, higher productivity, and career building for the students. So that is how we work on the learning journey. I would just take another 2-3 minutes on two of our training programs. One of the training programs is very relevant to what we have been talking here now. It is related to the building. So in this, you can see, I will zoom this area, which is very relevant to you. So as you can see here, we cover the technical aspects, the operation and maintenance requirement of electromechanical equipment. So sir has already introduced certain equipment names. You would have seen transformers, generators, UPSs, chillers for the air conditioning systems. So there are many other systems like the lifts, the escalators, elevators, then a lot of control systems, lot of monitoring systems. So we cover all the technical aspects. We cover the industry trends, which is the home automation. So when it comes to smart homes, in Schneider's philosophy of smart homes, we are training you on what are the automations which will come in homes, what are the automations which are there in building, which is called building management system. So IoT is a latest trend in that. So earlier it used to be wired systems, now there are wireless systems coming up. Energy management, sir has already spoken about in detail, energy audit, so that will be covered. So we will talk with relevance to what is required. So it will be, as Sanju said, this is a fast forward course that will run for months together. So our course is ideally designed for 3 months. But for students who are studying, we would prefer to have it spread over a 6 months period, so that over the weekends you can attend it. So the course features campus trainings on practical experiences, the labs, Center of Excellence labs, which are established by Schneider's in Bangalore. We would take you through the lab, and maybe in your college also, probably down the line they would go in for procuring those equipment. So they are nothing but the real life equipment. It is the same controllers which are running in the buildings. It is not a controller which is tuned for education. It is a miniature version. It is not a miniature version also. It is the same version which is which can control various inputs, outputs, air conditioning, anything, water management, chiller management, anything what sir has spoken about. Everything, whatever happens in real life would be present in this system as well. So this is a course which we call it as building automation and management. This is a 3 months course, but we would put it as a 6 months course for you because of the time period. So moving on to the next course which we have is on the industrial automation side. So Sridhar sir had spoken about the industry 4.0. So wherein there are a lot of automations happening in industry. So here we take you through the automation activities which happens in an industry. So in this course contents, this is an industrial automation specialist course. Here we will teach you on the various installations happening in industry, various operation maintenance of the motors and controls and activities which happen there. The PLCs, the programmable logic controllers, that is how it starts off with sensors. So it talks with the 3rd generation, and then we'll move on to the 4th industrial revolution as well. The pneumatic and pneumatic connectivity, interconnections, everything would be spoken about. And all our training programs would also add some amount of personality development, which will also help you in, probably this IT and communication skills are also part of your own career courses. So we would spend more on the requirement of the industry. So that's what I wanted to talk about. And this is our office address. We are located near Hebbal. And you can note down the email ID of mine and my phone number, as well as our website is provided there. I think that's what I wanted to cover in a nutshell. So I would like to take up any questions are there, and then pass it on to Sanju for moving forward. And the course fees are actually, we charge about 40,000 for the building automation and 50,000 for the industrial automation. Anybody who is interested from this team of people participating, or for the Anand Sagar, we are offering a straight 50% discount on that. So you can take these courses at 20,000 and 30,000, 25,000. So you can write to us, you can contact us, email us. So the number is also sorry, it is not +97, it is +919741. So this is also the WhatsApp number. You can send messages on WhatsApp as well. Yeah. So any other questions? Any questions relevant to this training programs? I can take it up. I think I can see a chat message here. Yeah. So this is for feedback only. So any questions, ma'am or Sanju?
If you have any questions regarding the training programs, you can put it in the chat window. So if there is anything, we will come back to you.
Yeah,
sir.
please,
Sure,
please. Yeah,
sure.
yeah. Thanks a lot. Yes, Sanju. So I'm through.
Yeah,
Sir,
over to
anything
Anna.
to add, Sanju? Okay.
Nothing in particular. I think we are done with the session, so you can take it up for the closure if the chair agrees. Otherwise, I leave it to you.
Michael, sir. So I request all the students to fill the feedback form. The feedback link is shared in the chat window. So we have come to the end of this session on energy audit and digitization. It was indeed a pleasure to have such a very vibrant event with many eminent speakers in the area of energy and sustainability practices. It is my I take this opportunity to thank the gathering. So first of all, I thank our speaker, Mr. Sridhar Shanoy, who is the General Manager, Energy and Sustainability Practice Services, Schneider Electric, Bangalore, for taking his time or sharing his knowledge with our students. And so sir has explained very well about the energy audit services, the power quality services, how energy audit is performed in industries using certain calculations, and also the significance of energy digitization and the technologies 4 years beyond the line. So thank you very much, sir, for the wonderful session on energy audit and digitization. So I also take this.
Thank you, Sridhar Shenoy sir, Sanju Santan sir, and Adi Narayan sir for your wonderful lecture, sir. Namaste, sir. Thank you. And it was a wonderful lecture, and the students are definitely going to benefit from this thing, sir. And rather than it's creating awareness among the student about the energy audit, because most of the student nowadays, they are the careless sort of thing, not aware and all this thing. It had created awareness. That itself is a very great thing, sir. And that this is a this is a particular module in our basic electrical engineering, sir. So and when it comes from the experts like you, then it student take it more seriously, sir. That was our main intention, sir. Sanjay sir, thank you so much, and Sridhar sir and Adi Narayan sir, it was wonderful, sir. And it's going to help our students in a very big way, sir. Thank you so much, sir.
Yes, yes.
Thank you very much, sir.
Thank you, all of you. Thanks, Adi. Thanks, Dilip. Thank you. Thanks, Sridhar.
Thank you, Anna madam. And
Thank you very much.
team.
Thank you all for attending this session. Thank you, students. Thank you, sirs. And so let's all try to make energy usage very efficiently, as well as try to make this world more greener and reduce the carbon footprints. Thank you all.
And it's the responsibility of younger generation because another 50, 60, 70 years.
Good thought. Good thought.
Thank you, sir. Thank you.
Yeah,
Have a
thank you
nice
so
day,
much.
sir.
Yeah, thank you so much.
Thank you, Anna ma'am. Thank you, Anna ma'am.